As we discussed, as we talked through the working components, or what we call the working components of the safety management system, that is the safety risk management and the safety assurance components, we realized that there's a lot of data collection and a lot of data analysis that is done in order to make decisions on how we deal with the hazards and the risk that's in the system. In this video, we're going to drill down on into some of the tools and methods available to you to conduct that data collection and to conduct the data analysis. So we're gonna get into some of those tools. First, though, let's talk about classification systems. The big college word they use in safety management system is taxonomy. It's not really a tough concept, it's just a long word, and it just means that the data collected gets classified or categorized into different buckets. That is, the end goal of the process then is to produce repeatable and reliable results. Repeatable and reliable results are actually very specific in this terminology as well. Repeatable means that given the same data, another reasonable person would come up with the same conclusion. And reliable means that the answer, accept the risk, mitigate the risk, or transfer it, is consistent and can be applied to the greater system. So you would think that coming up with a classification system is easy, but it's very much not. There's a whole science behind coming up with a classification system that includes the right categories, the right depth, not too many categories, but doesn't leave any out. We're not going to get into that in this class, but the main thing I want us to understand is that the purpose of having taxonomies is to help us categorize data obtained through the safety risk management and safety assurance components so that the data is useful for analysis. Your presentation and your text go into several more common taxonomies related to aviation, including things like Aviation Safety Reporting System, ADREP, and HFACS. When analyzing hazards and failures within the system, there are a large number of tools available to you to help objectively and comprehensively analyze the system. Your text covers several of these tools. We will cover a few in this video at a high level, just by way of example. So you'll hear the terms bottom up and top down in this section. You should be familiar with the terms. Bottom-up approach means that you start with individual parts of the system and work up to the larger system as a whole. It's like starting with a tree and moving out a step at a time until you can see the whole forest. Top-down, by contrast, starts with the forest, the bigger picture, system as a whole, and moves inward or down through the system, getting into more and more detail. When working through the failure mode effects analysis process, you will ask several questions. When you identify what can fail, you are logically led through the remainder of the questions throughout frequency or likelihood and consequences or severity of the failure. You should recognize that from the SRM components risk matrix. You should recognize this from the SRM components risk matrix. FMEA, however, adds one more element to the risk priority, and that is detection, which is really an interesting concept. Detection is simply what is the probability the failure would be detected before it impacts the system. And that is factored into the severity and likelihood criteria to give a bit of a more comprehensive risk priority number as compared to other identified hazards. Another tool available is fault tree analysis. That starts at the system level failure, like an incident or accident, and works down through the system, top down, into more and more detail to identify what failure or combination of failures could cause what they call the top event. That's the bad thing that we're trying to prevent. The fault tree analysis diagram has symbols that are in your text and presentation. Here's a simple example. In this example, if the power unit fails or a fuse blows, the power will go out and lead to a dark room. There are single points of failure. That's if the power fails or the fuse blows, either one of those, that's the OR gate, you will lose power up at the top. So those are single points of failure. The lights, though, are redundant. You see that both light 1 and light 2 have to fail, and the AND gate and light 2 have to fail in order for a dark room to occur. So those are redundant. There's redundancy built into that section of it. A gap analysis is another tool. A gap analysis sounds very scholastic, but it's simply the difference between where you are and where you want to be. We do this in our own personal lives too, though we might not call it that. We determine that we want to be qualified to do a certain job, so we evaluate what we need to. We evaluate what we need, and we obtain the education to get it, or the tools to get the job that we want. Gap analysis in SMS it's still a very analytical process that seeks to kind of comprehensively identify the current state and the desired state of the organization. And then you can build a roadmap from where you are to where you want to be, and build upon the processes that are currently in place to move in the right direction toward SMS implementation and continuous improvement. There are full college courses dedicated to individual analysis methods. The intention here was to just do a high-level overview of why we employ taxonomies into safety management, and the goal also was to introduce you to some of the tools available, give you a high-level overview, and to look into some of those tools that are available to you for the data collection, the data analysis in our hazard identification and risk analysis through SMS.